Good afternoon, ladies and gentlemen. And it's not the third Thursday, but it is Thursday the 3rd. And today we're going to do a recap as well as a little bit of sports science on our Geosteering World Cup final that happened on November 17th. Now I'm here with Igor Kuvaev, who is the man behind the scenes helping make that thing go. Igor, how you doing?
I'm good. Good afternoon.
So this was, I gotta say, one of the great things about working for ROGII is we get to do some, I don't know, varied things, sometimes some weird things, but they're a lot of fun. You're never stuck in a rut. And this was one of the more intense and enjoyable activities I've been in with ROGII. So I hope y'all enjoyed competing in it and watching it as much as we enjoyed putting it together. So what we're going to do today is we're going to talk a little bit about like what happened, how everything went down, but then also some of the things that we can learn from it. What were the key things that allowed champions to be champions, and how can that affect our actual day-to-day geosteering kind of skills going forward? So let's go ahead and jump into this here. Oh, and I'm in the wrong thing. Let me flip over here so I can click. There we go. Come on. Okay, so it went down on November 17th, and that, of course, we had a semifinal, and then we had a final. There were 50 finalists. We had 2 robots, ROGII the robot from Norway, and of course, Igor K's C4PO. There were 4 regions. We had 104 wells drilled, but at the end of it, there can only be one champion. And so Anton, I'm not even going to try to say the name right now, but Anton took home the World Cup in flying colors, dominated the actual final scores. So today what we'll do is we'll go through a little bit of what happened in each of the wells and what we can take out of it. Are you ready for this, Igor?
Absolutely, Dylan.
Okay, and so, I mean, obviously, while it was going on, everybody saw my face and heard my voice. You know, I was doing the broadcast, but Igor was working behind the scenes to make sure everything ran smoothly. Igor, can you tell us a little bit about what was going on that the audience and the competitors didn't see? What were you doing while that was happening?
So, believe it or not, we had tons of things happening on the back end. So, back end part is actually where Solar works. So, I guess most of you are using our Solar cloud system, and this is what made our Geosteering Cup possible. So what you see, stars here, is technically called front end, and majority, believe it or not, majority of the code, majority of our development these days is happening in the back end part. Something you don't see, something is sort of totally hidden from your eyes. And I was actually watching because it was a little bit of new experience for us, especially in semifinals when we had 200 people simultaneously changing the laterals on the same project. And this was actually also a very good test for us, whether, you know, this whole system works. And it worked perfectly well, smoothless, very smooth, no issues. But my role was to watch if we have any IT issues. Luckily, we didn't have anything. And, you know, to make sure it just, you know, works nice and smooth and you're all happy. And at the end of the exercise, my role was to quickly compile the results so Dylan and his co-hosts could announce it. Dylan, you're on mute.
Yeah, we get all the glory and you do all the hard work, right? It's how it always goes.
I did what I enjoyed to do, you know.
Yep, for sure. For sure. Well, let's go ahead and jump in here. Okay, so so many screens. Okay, so looking at our first well. So this is a well that I put together. It's based on some Permian data from the University of Texas lands. And all of you who've used StarSim, you guys know all we need to make a model is basically a type log, right? And so that data from the University of Texas public lands there in the Midland Basin, it's free, it's publicly available, so we were able to use that. And I use that to generate this. Now, of course, we had to, I mean, this is the World Cup final. I couldn't make it too easy. And in fact, in my head, I was calling this Elm Street because it was for sure going to be a nightmare. And sorry about that. But it looked like it was, if nightmares can ever be fun, this is going to be the one here. So what we're looking at here on the screen is this is the actual official structure. And all the competitors, when you finished your well, you got a new interpretation sent to you called answer. So you could see where your well was relative to the structure. What we're looking at here is all of the wells relative to the structure. And then also we've taken everybody's wells and averaged them together to come up with what would be the average well position. So here is the average well position in the solid red line. And then you see we have our standard deviation, 1 sigma here, above and below. Now, as we're going through here, I mean, the key thing, obviously, to these is always going to be the faults. But Igor, when you were putting together the kind of the analytics on the back end here and looking at these standard deviations, what were some of the things that stood out to you?
So I guess one of the most interesting parts was the fact that our standard deviation is increasing. So you can see how those dashed lines are getting further and further away from the average well. So almost immediately it made me think that, you know, it's a real life situation. The longer the lateral we drill, the more uncertainty we have in the geosteering process. This was a fairly simple example because our geology doesn't change laterally, right? Only the structure is changing. But think also about the case when your geology is changing. Your uncertainty will be even bigger. Mm-hmm. So at the end of the day, when you consider drilling long laterals, especially in complex geological environments, think about that. Your geosteering uncertainty towards the end of the lateral will be bigger.
For sure, and this is something, I mean, it almost looks real similar to the output from that Python script that we have that shows the ellipse of uncertainty from just the tools, right? It's a similar concept, but the reality is that there's uncertainty coming from multiple different domains. This is where one of the things I really like about the assisted geosteering tool is the little side tool that comes with it called Spectrum. And what Spectrum does is it allows you to see all of the interpretations in one visual, because it's very easy to just make a mistake early and not realize you've made a mistake and then make every other decision based on an erroneous correlation early on. And so I love Spectrum for that. So of course, little sales shout out, like if you guys want to check that out, the assisted geosteering tool will put you on a trial for it. It's wonderful. And Spectrum is amazing. Now, Igor, you helped develop Spectrum. So maybe next year, can you think of a way that maybe Spectrum could be involved in this in the final, just to be able to see all the different interpretations?
Yeah, sure. We can think of something like that. Spectrum definitely going to be a good tool, especially in those heavily faulted wells.
For sure, for sure. One of the big tools. Now, moving forward, let's go ahead and jump into what actually happened here on Elm Street. Okay, in our first well. So as we came in, I don't know, there was some nefarious geologic creator here who just threw a massive fault right in the bottom of the curve. And this threw everybody for a loop. So you can see all of our wells are coming down. Everybody's coming down here. Let me turn my little, oops, I don't want to do that. I don't want to turn on my little laser. Where's my pointer? And pointer, there you go. Okay. Back and laser. Okay, that's not going to do it. Don't worry about it. Okay, so coming in here, you can see that we're coming down through the curve and everybody lands low. But what we see as we move through here is the key to success, both in real geosteering, real life geosteering, but specifically in the Geosteering World Cup and specifically here on Elm Street, is the ability to recover from that fault quickly but safely. Like if you recover too quickly and you shoot out the top, that's a net negative for you. If you recover too slowly, you're now, like these folks right here, you're now missing a large section of it. So what you can see is we put together some statistics here. And so this was based on success factor. And remember, success factor is 75% based on your in-zone percentage, 25% based on your average ROP relative to the max ROP. So as they're coming down here, you can see Durasov, who actually finished second overall on this, spoiler alert, he actually was the very first person to get back in zone. And he's represented by this black curve here. The gray lines in the back, those are people those were finished within the top 10. And those who are white, those are the rest of the competitors who finished 11 through 50. So you can see that he was able to jump right back in here and stay within zone. But for the most part, though everybody got thrown for a loop, we all really were able to come back to kind of a meeting of the minds by right about here, about like 9,200. Now, Igor, do you have any thoughts on this first section?
Yeah, I guess as you said, Dylan, the key component here was to properly land and get back to the reservoir, get back to the target. Let's put it this way. We had a couple of interesting cases when people, when they were landing, when they were crossing that terrible fault, they were crossing it in a way that gamma ray before the fault and after the fault was exactly the same. And for sure, and of course, it's not because those people did something wrong or our model is wrong, just they got so unlucky. So for those people, identifying that fault was very hard because you can't really see it on image logs or on gamma ray because the character jumps substantially. You have to interpret the behavior of the gamma ray after the fault, and you have to quickly understand that, hey, it was a fault. I need to get back to the target as soon as possible.
Yeah. I had one of our competitors reach out to us and say that he wanted to find out who our geophysicist was who built this structure so he could fire him. Well, Igor, you're actually our geophysicist. So how could there be something like this it trends correctly, but I mean, there was 4, not big faults, but not real small faults either, and none of them were predicted just based on the structure, based on the well plan.
From geophysical standpoint as well as from fault standpoint, it's an interesting structure, and there are not many people that geosteer places like Niobrara with faults like that with 3D seismic available, but in those places you can see that if you have seismic, well, here we didn't have seismic, we didn't provide seismic. If you have seismic, it sort of helps. You see some indications that it could be a fault here and there, but seismic won't be able to tell you that, hey, there is a fault of 20 feet throw. It's just not enough. It's not enough for seismic to show it to you, especially at those depths. So, everybody was in the same situation here, so nobody had seismic, and that structure map that was provided was sort of intentionally built in a way that, regular person would build it from seismic data, and seismic data will just show you the general trend, general structural trend. Seismic data won't show you the faults in this area.
For sure, and I think I've seen a lot of different operators that I've worked with personally, and then helped since I've been with StarSteer with ROGII, and that is a very common setup for a well plan. Like, it basically takes you into landing, and then they just say, all right, this is the general trend, this is the inclination, but of course that there's going to be variations from within that. The other thing that we took into account when we were building this is uncertainty with the tool. So when you're looking at the grid, you'd actually see that the grid actually moved further and further from reality the further you went out into the wellbore. So we're trying to make it as realistic as possible without making it too easy or too hard. So as you can see, coming out of this first kind of section here between the first fault and the second fault, this was our leaderboard. And by the way, we're having a really beautiful video made, and it'll actually it's very Formula One, very NASCAR. And it'll have all the different people with you'll see your wells growing, and who's in the lead. And of course, we'll probably do a little bit of color commentating by yours truly on there. But this is kind of a taste of what kind of flavor you can expect with that. So you can see that Mr. Dursov here, he was in first place. And he already had a pretty good lead based on the fact that he got in early. He was 4 points ahead our eventual champion, Anton Zyapkin. And who, if you want to see a little bit more about him, we went ahead and did an interview with him. That'll be published here pretty shortly as well. And you can see here's the rest of the group. But we can, poor Rosie, she didn't do too well. C4PO actually did okay. He was in the middle of the pack. But there was already a pretty good spread between the upper echelon here and the lower echelon. And this really came into play further into the well and into the competition. So as we move past that second fault, come on, second fault. There we go. Okay, and we move over towards 10800. So now we're looking at this section right here. So we hit that second fault, and we started all together. We got kind of spread out, and then we come all back together, coming through that second fault. Everybody was pretty constrained right here. And now, once again, it's a matter of, okay, you've hit this fault. You've been able to identify the fault. You hopefully have been able to correlate and interpret where you are relative to the zone. Now you have to decide what to do. Right, so you can, if you come up hard, or you come up soft, or if you just want to get a little bit more information. So looking at this, once again, we can see that standard deviation is actually growing as we expand out. And we can also see that, we had some of our better competitors got back in there later. And as you start to see the people who didn't make it back in at all, or got back in further down this section, they just eliminated themselves pretty much from competition for this well, with looks like one exception right here. Igor, any thoughts on this section before we move to the kind of where things started to get really exciting?
No, not much, Dylan. Let's go to excitement.
Okay, so in looking at this, I want to just point this out before we go any further. So at this point, even though he dropped a little bit from his 83 success factor in that first section, Dursov, he had a pretty solid lead here, and you can see that Anton was 11.1 points behind. We're over halfway through the lateral, right? And Nick Driscoll's right here. You would think that if anybody's going to make the move, it's going to be him, but even he's almost 9 points behind halfway through one lateral. So as we move on to the next piece right here, this is where things start to change. So once again, the black line is still representing our leader, Durisov. And as we go in, you can see that they came through this fault, and he came up and he got into zone relatively quickly. But if you see this little line right here, this is Anton, our eventual champion. And he came up and he gained, several hundred feet on him right here, which allowed him to go from 11 points back to 2 points back. So this was a major change in how the leaderboard looked. And once again, also you see this is where we started to explode as far as our standard deviation. Now I've taken off all the other wells so we can really coming into the final concentrate on our 10 leaders. Anything on this, Igor?
Yeah, I think what is really interesting that if you look at the surveys or trajectories of 10 best geosteers, they all go together pretty much, with very minor differences. They all follow in each other. And but at the same time, our standard deviation is getting bigger and bigger. Remember our initial statement at the very beginning? Mm-hmm. So, it makes me think that there is a certain strategy that all 10 best geosteers were following that makes them so similar to each other.
For sure. And you got to think that, they say everything's a game of inches, or in this case, a game of feet. And you just got to think that the difference between finishing at the top, getting that Apple Watch and getting that trophy, and just having a nice story to tell is just a matter of, did you move that target line up right away, or did you move it up steep, right? And then you even look back right here, there was the person who they made the top 10 despite this soft landing. I always thought this one was pretty interesting back here. Because they didn't end up losing much because they actually got into zone at the same time as everybody else because they were, vaguely ready for that fault. So there's different strategies. So let's go ahead and move into the checkered flag section here. Okay, so now we're coming into the end. I got my little video in the way here, and you can see that it was neck and neck, right? At the very end here, as we come through this last one, I have it set up right now with Anton as is now the black line because he's our leader and champion here. And you see that what he was able to do is he was able to get back in zone. And right here, everybody was in the same spot. I mean, there's just a few feet difference. And everybody's basically at the same inclination coming into that final fault. And this is where this well was decided. Right there, between number 1 and number 2, this is where it changed. And Durisov thought maybe that the dip was going to be a little bit steeper right here, and he got caught when it started to flatten out. He went out the base, and he was never able to recover. So he went from a 2-point lead to almost a 3-point defeat, still with a great score of almost 60. But this is exciting. This is why we watch sports, right? I don't know if you want to call this nerd sports, but I love it. I was super pumped when I was going through this. Igor, comments on, from a technical aspect, what you're seeing here?
Yeah, I guess I agree with you, Dylan. It's that final part. I mean, the most interesting thing for this well, I guess, how close the results were, right? It was fair. I mean, all the people finished all the winners finished within very minor differences between each other. Mm-hmm. Unlike the second well that we'll show soon.
Yep. But one thing that we did see here is there was a large differential, right? You can see it here. Even in the top 10, number 1 was at 63% in zone for a success factor of 66. But if you go down to just number 10, there's 22 points that separate them, right? Like, it's hard to imagine somebody making up 22 points in another well, especially since our Anton here, he won both wells in the semifinals with the highest score, and now he's got the first well here with a 22-point lead over some of his competitors. Puts him in a real strong position. And so now we have to ask, well, here's a little close-up, right? You can see these were the two places where it really started to differ. right? So this was where Anton was able to get back into zone a little bit earlier here, right? So he gained a few hundred feet. And then this right here. These were the 2 points that decided this round. And eventually, as you'll see, probably decided the competition. Well, partial part of it. Now, the question, of course, becomes, what did our champion do? Like, what did he do that made his ability to identify these faults and recover and get back into position so good or so fast? And here's his breakdown, right? So what we're looking at here is this is the answer key interpretation. This is his interpretation, right? So you can see his interpretation is really, really strong, really clean, matches up real well with what the answer was. You can see that he's not a super splitter, maybe a little bit more of a splitter than I am, but overall he's pretty spot on. And so the question then is, like, how did he identify where these faults were? How did he get his correlation so strong in time to be able to react and move his wellbore? And the answer is image logs were the absolute key. Now, if you look up here, here in North America, all of us have maybe seen image logs, maybe we've even used them. For the most part, we just use total gamma. We rarely have any even up down, let alone some of the big, 4-channel, 8-channel, 1632. But when you're looking through here, as you can see, although it's a little bit hard to identify right here, this is very obvious that we've just crossed a fault, right? You see this very fine vertical line. Here's a second one, and here's a third one. So by being able to use those, but also being able to identify where the wellbore's inclination relative to dip by looking at your smiles and your frowns, he was able to rapidly be able to recover from crossing that fault and get himself back into zone. Now, Igor, I know you've spent a lot of time looking at image logs over the years. What are your thoughts on that?
There is, of course, our image logs, the ones we provided, were probably a little bit too ideal. I've seen those perfect image logs only, when you drill with rotary steerables with very good image logging tools. Don't want to name the vendors, but not all of them are good. Not all of them are good.
Right.
Also, in addition to that, it's pure geology plays a role here. As we said at the very beginning, if you cross your fault and if your gamma ray before the fault and after the fault is the same, image won't help you. As we can see from this example from Anton's geosteering, he was lucky enough to cross those faults at the places where gamma ray changes, so he was able to identify them quickly.
Yep. To sometimes there is just a little bit of luck involved, right? So if you look here at these, you can see that depending on where you cross that fault. So he crossed it right here, right? Or excuse me, he crossed it right there. And as you're coming down, you can see that there's a lot of similarities between the magnitude that you see here and the magnitude that you see here and here, depending on where you were when you hit it. So there's a certain amount of luck, and of course in the real world there's other parameters that you would look at to be able to determine had you crossed a fault. You're looking for that drill break. You're looking for were there any losses? Was there anything else in your drilling parameters that changed that help you identify it? But this is another one of those things that's an art. I would say that for 90%, at least North American geosteering, we hit subseismic faults pretty regularly. And when we hit it, you don't often recognize it right away. All you know is just all of a sudden your correlation doesn't work right. And then you have to work backwards to try to identify, okay, where could there have been a fault?
Okay.
And of course, then there's the infamous geosteerer's fault. Which is your correlation wasn't very good, and then you figured out where you were, and then you just say you crossed the fault to get down there. It's the geosteerer's magic fault. So anyway, so image logs were indeed the key here. So after we finished with all of those wells, right, and as that is going on, Igor's furiously calculating to figure out who is the champion of the first round, where everybody sits. Andrei Popescu, who's our product owner for Starfrac, took those wells because once again, they're in solo, right? The data's all right there. And in an amazing opportunity, you've just had 50 different geos, talented geos, some of the best in the world geos, drill 50 wells in the same location. So he ran a script to basically spread them out so they didn't have the exact same surface hole location. And in less than 5 minutes, he took those 50 wells that had been drilled. He modeled their well properties. So you're looking at these colors that you're seeing here. This is density porosity modeled. He planned his stages for all 50 wells, and then he visualized them. This took him less than 5 minutes, and he was able to come in and do a presentation. I don't know how long that took you when you were working at an operator, Igor, but one well used to take me an hour, 2 hours to do.
Yeah, it's an interesting concept, and the reason why we wanted to show it is because it actually shows us the value of geosteering right away. So we can check all of these 50 wells, and all of these wells were drilled in exactly the same geology because we know that, right? We created that geology, and all these 50 wells were drilled by experienced geosteering people, and now we can see what kind of completions difference it will create for us, and that difference is quite substantial. And so it's not only just planning the completions, which is awesome. We can do it automatically, right? But it's also doing this smart planning the completions, making sure those stages were placed outside of the faults. They're placed in the best geology, and we actually see what kind of rock we're completing at each stage.
Yeah, I'm super excited because I think next year, and no promises, right? Because this was a lot of work this year and we have to figure out what we can do. But we'd like to even integrate this more. Like we have some ideas of how, instead of having some sort of success factor, in this case, it was just a 2-variable success factor, we could actually work with ROI using StarFrac, right? So people will drill their well, and then we'll put it into StarFrac. We'll obviously have to define some variables for it. And then we can decide whose well is actually has the best return on investment. And so I'm the eager beaver there. So we'll see what I can convince everybody that we need to do with that.
Yeah, that would be a perfect place to merge our rate of penetration with completion efficiency with production, because it all influences our ROI. Mm-hmm.
Yeah, it's nice to see all the data finally coming together instead of all different people in different rooms on different computer systems. So we can finally all kind of bring it together into one, bear with me with my dad joke here, one solo system, if you will. Okay, I got jokes. Anyway, all right, so moving on, we got a little video, little animation. If I can get it to come up here, here we go. And so these are the 50 wells right here, right? So we just spaced them out a little bit. And this is something, maybe a little bit of foreshadowing of what we're going to run into next year. So these are the laterals, those discs that you see coming out, those are the stages. And he's actually going to focus in here on Anton's well. All right, so he'll bring this in. All right, and so this is the best well that was drilled right here. And so, we're doing it based on ROP and in-zone percentage. But what this would actually allow us to do is say, all right, well, who was able to place the most stages in the highest porosity rock, right? This is fascinating stuff. So once again, if you'd like to take a look at StarFrac, give us a call, reach out to your account rep, and we'll get you set up with a trial or at least a demonstration of it. Okay, so now moving on to well 2. Okay, so well 2, this was the conventional. And Igor, can you jump in here and kind of tell them a little bit about the strategy and the background of this well?
This well is actually, it wasn't created because we wanted to torture you. It was created based on real life situation. This is the well that we experienced. This is the well of real geology. So the interesting component here was that it's a tight sand at the top, followed by reservoir, followed by coal. So from gamma ray standpoint, it's a purely symmetrical reservoir. So above and below, the gamma ray behavior is almost exactly the same, with minor differences that you need to catch. What is different is resistivity. So you need to look at the resistivity to understand whether you're drilling up or down. Additionally, no image logs were provided. Also, our experience, because when we experienced that well, we didn't have image logs. So we struggled a lot, the same as you. So the key component is to use all the available data. In fact, resistivity is the key, as I said. Additionally, there are minor changes in the reservoir. So when you're using stratigraphic geosteering, you can see those minor reservoir changes that are not available in the type well. And if you're carefully looking at the data, you can identify all the structural changes. You can identify this major fault.
And one other thing that was I thought was probably useful is there's some ROP variation with that coal, right? So that Correct, was the other way, which it works with the resistivity to be able to say, all right, like And I was actually curious if somebody would decide to go whole hog on just max ROP and just sit in that coal seam. So basically 3 different logs that you're going to be able to, we're able to use to be able to identify your position. So gamma, resistivity, and ROP. So this one, it was a little bit simpler. Like he said, this was a little bit more realistic and a little less Hollywood geologic horror movie. And what you see here in this chart is we have what's going on this particular well, and then how that relates to their cumulative setup. So as you can see, there is, starting off, there's a pretty big lead that was going to have to be made up on Anton for anybody to have a chance, right? He had about a 6-point lead coming into the early part of this. So as we're coming down, you can see that everybody was pretty much the same, So there was a few people who went out the bottom, but only one of them actually ended up coming back and being able to make it into the top 10. They had a really good well after that. But everybody else was able to kind of get down, and we're real bundled up here. We start moving forward, and now we're coming up on this fault. Now, once again, no image logs this time to identify the fault, right? You're doing this purely off stratigraphic geosteering and a little bit of expectation based off of your well plan and structure. So with this, they come in, and you can see right here, he's still got a pretty good lead, but he does have some challenges. So let's go ahead and bump to the next slide. And this is the last slide for this well, and it tells a really, really interesting story. And so I'm going to talk about kind of like the drama of what was going on here. And then Igor is going to come back and tell us a little bit more about technically what we can see from this and how this would affect our own geosteering decisions going forward. So you can, if you remember, at the end of the first well, Durasov and Zyapkin, they were neck and neck. There was just a few points that separated them, right? I think it was like 63 to 59. And they were coming along, and they both landed in zone. There's a little bit of differential right here, but they were in zone. They were only separated a little bit by ROP. And then, of course, they hit right here. They hit this fault. And this is where there's 3 things to talk about here. This is where Andrea Infante, who actually dominated this well, got the best score on any of our wells that we had at all, and actually pushed her all the way to second place. She was the one. And this is where she got that position. As she came through that fault, she was able to recognize it, and she gradually and smoothly moved up into the zone. She recovered from that fault. She was the first one in, and she never left zone after that. She had an amazing well. Unfortunately, she just didn't have enough points from that first well to be able to recover. Remember, there was a 20-point gap between Anton and 10th place even. So right down here, this is where the World Cup was decided. It was neck and neck coming out right here. And when they hit this spot right here, they both realized that they'd crossed something. And Anton decided that he needed to go up. Durasov decided he needed to go down. And as he started to come up, he didn't come up very fast. In fact, he was one of the last ones to make it back to zone. This cost him in this well, but he just had big enough lead to be able to make it. And by the time Durasov realized what would happen, we all recognize this, right? You have that little bit of panic. You've gone on this fishing expedition. You're looking for that marker. You finally realize you've gone the wrong way. And he went up, and he went up hard. So that even when he did make it back to zone, he wasn't able to turn it back over and recover quick enough to be able to actually get back in zone at all. So at the end of this decision right here that they both made is what gave Anton Zyapkin, our World Cup 2020 Geosteering champion, the title. That was it right there. Now, from a technical aspect, when you look at this, Igor, what do you see?
I guess I was just generally excited to see how much of the separation between different interpretations we see as soon as people cross that fault. So we definitely see that like roughly 50% of participants went the wrong direction. Majority of them actually found their way later on. If you look at all the geosteering interpretations, even those top 10, you can see that towards the end of the letter, most of the people realized where is the fault, where is the actual structure. So they actually were able to find it out.
And it's a situation where there was some really, in fact, overall, the average score on this was much, much higher on the second well. That might be because it's too easy. I don't know. Maybe we need to go a little harder on them next year. But it is geologically accurate. This is a real situation that's been encountered. So I think it was really interesting there. And at the end of it, you can see that we had Anton. ended up in first place. Andrea moved all the way up into second place with this amazing finish she had here. Mr. Pat Tobin, he was pretty consistent through the whole thing, number 3. Our mystery knight, who came over from a company who won't let him say his or her name, actually got 4th place. Robin, which we also have an interview from, he's down in Aero Energy down in Australia, and the rest of the squad here. Now, not doing quite so well was C4PO and Rosie the robot, but at least C4PO, he had a little bit more training and he was able to put a good solid whooping on Rosie. So I've heard rumors that next year there might be some sort of like Rise of the Machine robot battle royal. Are there more robots coming?
For sure.
Oh.
I can promise you that.
Oh man, that's going to be so much fun. All right, robot on robot crime is coming for everybody here. Now we had a LinkedIn post that you put up, and there was a really good comment on it from Mike Millard, and he said, "What happened here? Is this person some sort of wizard, a soothsayer? Like, how did they know that fault was coming up? I mean, here's the structure. I mean, here's the well plan, right? We can see maybe something's coming up. Well, I reached out. So this is Danica Watson's well right here. And I reached out and I asked her, like, what were you thinking? Like, did you hack into my computer and get the answers? Like, what was going on here that you saw this coming up? And her response was that as she was moving in here, she was looking at that structure and almost had a little bit of PTSD after all the faults on the Elm Street well that she just finished. And she was expecting a fault. And so she made the strategic decision that there had to be a fault coming up. I mean, we're halfway through the well, and she knew that we had to go up if this was going to be even generally correct. So she just jumped it, and she jumped it early, way before anybody else even thought of jumping it. Now, a few other people, they decided to try to jump it a little bit closer, and I really like the fact that they went for it, and then they were like, oh God, oh God, oh God, and then they were like, it's not there, it's not there. Unfortunately, by that point, it was there, and they started coming down only to have to go back up. So anyway, that's what happened. And so that was Danica Watson making, I think, maybe what's the word? The biggest cowboy move of the entire event. She went for it hard. I love it. I love it. Igor, anything on this at all that you want to bring up?
No. Let's go to the next one.
Okay. So now that was the recap part of this. But also, I hope some of you guys have had the opportunity to watch some of the sports science stuff that the different organizations, different media organizations are putting out, because they look at not just why somebody's a great performer, a great athlete, but what are the specific things that they do that make them unique. So Igor's put together some analytics that really help us dig into what makes a champion when it comes to geosteering. So Igor, I'm looking at this, and this is beautiful. I hope we can get this on a t-shirt or a hat or something like that, because I will wear it. But I have to acknowledge that I'm struggling a little bit trying to understand exactly what it is. Can you walk us through it?
Yeah, besides the fact it would be a perfect print for Geek t-shirt, it's a statistics on our Geosteering Championship, the whole one, not only the final. So please concentrate just for like 20 seconds to understand what is it, and then the truth will be open to you. So these are the statistics for 4 wells that we drilled, because we've got 50 people that drilled, 50 finalists. Each of them drilled 4 wells. And this is the statistics only for those 50 best geosteers. And there is a 5th line, which is the final rank. Let's ignore it for a second. Let's focus on those 4. So what we see on these 4 is actually the rank that each person took at each well that was geosteered. Semi-final wells, conventional, unconventional, final well. The same. Actually, this one is unconventional and conventional. And so basically, the lower the line is, the better the rank is. So what's the value? We can see how each person performed. I mean, we don't have the names here, but at least we can see whoever was the best one. How each person performed at each lateral. And at the end, there is a final rank. So of course, we've got top 10 geosteers, and these are displayed as bold lines here. And you can see how each of those persons performed at each lateral. So probably the most interesting outcome here is why we have a winner and why the winner is the winner. That person, Anton Zyapkin, he was just almost the best one at all the laterals, except for the very last one where he came 4th, and the first one where he came 2nd. Other than that, he was, the first person in 2 laterals consequently. Very good result, very consistent, very good result. Would be interesting to see whether, somebody will be able to, beat him next year or not. Second person, Andrea, she is very interesting too. You can see that the first well, she did very bad. Probably she was just learning how to do all of that. Maybe didn't get, how the whole process works, the first semifinal well. But then she got consistently better and she won the very last well. And but even before that, you can see how her results was improving. So again, very consistent person. And keep in mind that the final rank is combined only out of 2 last wells, right? Because this is semifinal, so this doesn't go into final rank. And generally speaking, if you look at all other wells drilled by top 10 geosteers, you can see that those people are actually fairly consistent. So it's not that you have to be always the first person in the game, but you have to be consistent. All the top 10 geosteers, they were always, well, I would say generally in the top 25% or at least in top 50% for almost all of the wells, maybe except for the very first ones. So it's not and we vice versa. We had persons that actually were like the best or almost the best at some of the wells, but they just didn't do it very good at all other wells. So, and it didn't, make them, it didn't give them any good ranking. So it's not that you have to be the best of the best all the time. You have to be consistently good.
For sure. In fact, I'll admit, when we first started working with this and I started just kind of playing around with it, we did a little North American Geosteering League. And what I had expected to kind of see was that it was just going to be maybe luck, like that we weren't really going to be able to capture the true talent, the true skills that are involved here, right? It's too abstract compared to reality. But then you start to see that certain people tend to score higher continuously, and then that there's a pattern. There's got to be a reason for it. Now, this doesn't necessarily mean that these people are the best geosteers, but there's something that's going on that is tied directly to their ability to geosteer within StarSteer. So yeah, it's fascinating. So fascinating, in fact, that I think we're going to look at maybe publishing a paper and doing some talks at some conferences this year. So if you happen to see us on there, come check us out. And
next year.
Well, maybe or next year, yeah, for sure. 2020 is done, hopefully.
Yeah.
Knock on wood. Yeah, but so if you happen to see us, come check us out. It'd be, I think, some interesting talks. I don't think there's ever been anything quite like a geosteering championship as a subject matter for a study. So is there anything else you want on this, Igor? Or should I move to the next slide?
No, that's it. Next one.
Okay. So go ahead.
Yeah, go. This one is interesting too. Sorry, Dylan. This is actually comparing 2 things that were just, 2 things that I expected to see that I didn't see here. So it's comparing the success factor of the first well in the finals, we call it W3, and the second well in the finals, W4. So conventional versus unconventional well that we geosteered in the finals. So it compares the success factor for each person for both of these wells. My expectation was to see, whether, that if the person was successful at the first well, he or she should be successful at the second one. No, pretty much there is no correlation whatsoever. My second expectation was to see more of the success with conventionals in European part and more success with unconventionals in North American part. No, didn't see it at all as well. So kind of slides that show that none of my expectations actually happened.
Your null hypotheses are now null, right?
Yeah.
Yeah, and it's interesting because we talked about in the U.S. we kind of, I'm not gonna say we invented the unconventional, but we kind of invented the unconventional, and you would expect just to have a head start because that's what we do every day. But with a few outliers out there, the highest scores that we got at the unconventional were both from Europe. So it was very interesting. And so I guess what you're seeing right here is that combination of success factors. And with the exception of like one person right up here, it looks like there really isn't too much in the way of correlation. Now, here's that second one that you were talking about as far as the success factors by region, right?
Yes. Mm-hmm.
And so in looking, and go ahead, I'm sorry, go ahead, Igor, it's your slide.
Yeah, no, absolutely. So it's pretty much previous slide, but showing the histogram view. So it's success factor as a histogram based on the region. So in South America and Oceania, it's excluded because no statistically meaningful number of points. So we have only Europe, Middle East, and North America here. So you can see the success for unconventional and conventional wells here distributed. So if you look at the distribution, so look at specifically at Europe in blue and North America in red, you can see that on average, North America geosteered somewhat better than Europe for unconventional well. And on average, actually same for conventional, on average, North America geosteered better than Europe on conventional well as well. But there are a number of outliers, a number of people from Europe, just a small group of people that geosteered exceptionally good, that made them in top 10. So even though on average America is better, the distribution of European geosteers is wider. That actually made a champion and make them good geosteers.
Yeah, there's a word that we use for outliers like that. Champions. There's an entire book written called Outliers, and it just talks about like how do these outliers happen? We all come from the same population. How do you get Wayne Gretzky, Michael Jordan, and Anton Ziapkin? Right? Like how do you get somebody who just appears to perform better in a particular situation than the competitors? So honestly, fascinating. So moving on to the second to the final slide here, looking at dog leg severity and how that affected the success factor.
Yeah. So interesting message here. So again, something that I expected to see and it didn't happen. My initial concept was the higher the dogleg severity, the higher success factor is, because we see a change. We change our target line. We go to the target line as fast as possible. It increases our average dogleg severity for the lateral and increases our success factor. I mean, somebody can see some sort of correlation here on this plot. So the higher the success factor, the higher the dogleg is, but it's very low. So we don't see anything substantial to conclude that. So it makes me think that it's not really high dogleg severity that makes our well successful. It's the decisions. It's the decisions that we take. And I guess, Dylan, you have something to add here as well, right?
Yeah, well, I think that one of the things that probably is the case is if you remember when we had our first geosteering competition back in 2018, we didn't have a limit on the dogleg. Right, you could literally drill backwards, and some people figure that out, right? Like you could go straight up, straight down, and so as soon as you're out of zone, you just moved right back in. Completely unrealistic, at least for most operators. Ha 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 ha. Boom. Anyway, so but I think what happens is if you do react like that, right? Like you decide, okay, I'm out of zone, I'm low, I'm going to start going back up. It's really important that you know exactly what that bed dip's going to be, because if not, and we saw this over and over, right, is you can come up hard and you can get back into zone, but you can't stay there. And of course, in the real world, even if you put in that slide, you come up hard and you get back into zone, and then you have to put in that slide to come down. Now, one, that slows you down. Two, that upsets your directional driller. But then you end up in a situation where it's what some people call the roller coaster road, other people call porpoising. I like the analogy of you are a drunk driver on an icy road at night, and you just swerved and avoided that deer, but now you can't get back control. And you spend the whole rest of the well, or at least a long bit, swerving, or in this case, sliding over and over just to try to get your wellbore back under control. So really, and this kind of it's evidenced here. I think that's why you see this noise in this signal, is that like gradual decisions, like moving back towards zone gradually, even if it means that you don't get back to zone quite as quickly. If you're not in an emergency like situation where you're about to lose your wellbore, if you stay where you are, it's better to move up smoothly. And and this lines up with general concepts of geosteering, I think. All right, so moving on here. All right, so this is our last slide on this.
Yes, so here we try to compile some statistics, not purely on success factor, but also on the accuracy of the geosteering model. So each well, as you remember, at the end of the exercise, each of you got the final geosteering model, got the answer model. And here on this slide, we're actually comparing your geosteering model. At each dot, we're comparing your geosteering model with the answer geosteering model. So how close each competitor was to the actual answer. And this is displayed on y-axis. So the lower you are, the lower the number on the y-axis, the better is the match between the competitor's geosteering model and the answer geosteering model. So those low numbers, it means that a majority of the geosteering model was quite close to the answer. And the success factor goes on x-axis. And it creates us actually two areas. First area, I called it good geosteering, and second area, I called it high success score. So interestingly enough, they both intersect, and they intersect, of course, at the winners, at the people that did the best geosteering. So what's the message here? That you can come up with a very good and accurate geosteering model, but it's not, if you can do that, it's not guaranteed that you will result in high percentage in target and high success score, because geosteering model is not the only thing that you need to do. You need to also make sure that your well is in target, and that corresponds to the intersection of those two rectangles.
Yep, for sure. And you can see right here, these are the two Europeans, right? This is Anton, and how do you pronounce his first name, sir? Igor?
Evgeny.
Evgeny. So Anton and Evgeny, you can see that they had a great first well here, and also strong correlation. And I think, the reason why you see the split between, you have people who correlated really well, but they didn't necessarily do it as well. And it's like you said, you got to be in zone, and that was a nightmare, right? There was four faults, one of which had a throw that went the opposite direction as the other three, right? Which threw a lot of people off. Another thing that I'm interested in is because, this goes back to what we were talking about as far as, you would expect North Americans to do better in unconventional and Europeans to do better in conventional. And I really wonder if it really is just, obviously there's other factors, but if a large part of it is people in North America don't have the experience that Europeans do with image logs. I'd be willing to bet. Now, the cool thing is StarSim is part of everybody's StarSteer, right? So you can actually do these for yourself. We're putting together an entire library for ourselves to be able to use, but you guys can do the same. And you, of course, at Operators, you have all kinds of data to build this off of. So you can build these, and you can start actually practicing and working with image logs just to kind of flush out your toolbox if you thought that was a little bit of a struggle for you. So anyway, that is the end of this first section of sports science. We're still going to do some more digging. We have a video coming out that's really going to basically be a condensed version of the competition. And I think it's going to be really cool. We have some interviews from our various champions. Everybody should be getting their certificates and letting them know their world rank as far as the Geosteering World Cup goes. And now, we'll move on and we'll start talking about next year. So we hope to see every single person who competed this year, but also I think we're probably going to see 400 to 500 people competing next year. So when I interviewed Anton, he had his final quote was when I asked him if he was going to be able to defend his crown was easy peasy lemon squeezy. So now lemons can sometimes go sour, but somebody's really going to have to step up their game if they want to challenge Anton after the incredible performance he put on this year. So once again, thank you guys very much from the ROGII team, from the Geosteering World Cup team, from myself, and from Igor Kuvaev. Have a good one.
Thank you. Have a good one.